keep your eye just above the window here. It shows steps as they're being recorded. At this point, we can see what has been recorded, and all the steps we've done, all the clicks we've done, have been combined by the clever bits behind Coded UI into one launch command. So it doesn't record things like the individual cursor positions or whatever. It's clever in the way it does its recording. So we've got the correct thing to start our calculator. So we just generate some code. And we give it a useful name here. And this is just a small demonstration, but we could put here some useful description. And I'd advise doing that if you're creating real applications, real tests, where you have more than just a simple step there. Then we click Add and Generate. The screen kind of flashes a little bit whilst we're doing that, and the step has been recorded. So we want to resume recording now, do the next part. Note the little symbol has not shown here. What we want to do is do some arithmetic. So I'm going to type using the keyboard the number 2. I'm not going to click the button because in the future I want to data drive this test, and it's easier to use the keyboard entry at this stage than clicking buttons if I'm data driving. I can do it, but it's more complicated. So that's sufficient on this one. And again, I like to check most times, even every time, that I've got the correct steps recorded, because sometimes I get more things there than I need. So we'll generate this one. And I'll skip the descriptions for now. So we generate that step. Now I want to generate my operator, so I've clicked record again. Back over here, I don't need to move the mouse over there actually. Click an asterisk, you see the multiply symbol comes up, and just above the record button, I've got the message, it says type something into the to label. So pause the recording, show the step. For some reason I've got the left shift key has been typed there. Don't know why that came up. That's why I advise checking the recorded steps every time. We don't need that one. We just need to type the asterisk so we can delete that step. And then we generate. And generate that. Now we want to resume recording to type the second number. So if I type something like 5, again using the keyboard, and pause it and show the correct step has been generated, and enter the number. So now we want to actually do the arithmetic, so resume recording. So if I click the button this time, just to be different, we see the answer on the screen. We pause and look at this, and it shows the equals button with the word click. You'll recall before it was using type number into some box. And generate. So we generate the code like this. And the final step we want to do is closing the calculator. So we resume recording and close the calculator by clicking this close button. Pause and check that's correct. And generate. Now there's a difference between Visual Studio 2010 and 2012 here. In 2012 you don't actually need to close the calculator. If Visual Studio will close it for you. In 2010 it wouldn't automatically close the application under test at the end of a test run. but I'm going to close it. Oops, wrong button. Add and generate. So now I've finished creating my code, so I can close the recorder. And here I've got my code now, and if we look in here, I can quite clearly see the 6 steps that I've recorded. We can look at the code inside them if we need to, but we can see clearly that these are doing the things one does to drive a calculator. So at this point, if I right-click here, I can run my test. Now, whilst I'm running the test, keep your eye down here in the bottom left-hand corner of the screen, and also keep an eye on this grey bar at the top here on the left-hand side. So I'll run the tests. Now, down in the bottom left, you see that the build is started and it's doing its building things. And now the grey bar has got a moving green line. The moving line signifies that the test is in progress. And whilst the test is running, we've got to put our hands in our pockets, because if we start moving the mouse around or using the keyboard, then we can interfere with the way the test is running, because the test takes over the mouse and keyboard and drives them as if we were physically driving the devices. So when the test completes, the grey bar goes to a solid green colour, showing the test has passed. It might go to a solid red bar if the test fails. In fact, it would go to a solid red bar if the test fails. So here we have a simple test. Realistically, all we've done is shown that we can drive the calculator and do a little bit of arithmetic. We need to do more in this test to make it useful, but we'll come to that a bit later. So let's come back to our slides. So what is in a coded UI test? How is it built? We get 4 main pieces of code. The file coded UI test.cs is where we write our main code. I showed the 6 steps that were generated, and they go into that file. We can change the name of that file to something more meaningful for our test. We can have a test containing many of those files if it's a big test with lots of actions in there. And small files generally are a good thing, so that you can focus on individual concepts rather than having everything in one place. The code that's generated for us initially goes into the file uimap.uitest. Inside, that's an XML file which you could edit if you really wanted to, but we definitely recommend against it. There is a proper editor for that file, so you can edit it that way, but generally don't edit it as a source code file. The uimap.designer.cs file is generated from the uimap.uitest file. Every time we change the uimap, the designer file is regenerated. So any edits you make into that file, it's not read-only or anything like that, so you can edit it, but if you make any edits, then they will be lost when the file is regenerated. Associated with that file is the uimap.cs file, and we can move bits of code from the designer file into the uimap.cs file should we require to make source code changes to the text that was in the designer file. So we can edit the code there, but we have to move it into the uimap file. And it's probably worth moving the code first and then editing in the uimap file, just in case you get distracted and then lose the edits because the designer file is regenerated. So we'll have a look at the code of this. So here's the the file coded UI test1.cs as shown on the slide. Over here in the Solution Explorer, we have the UI map file and the source file that we're looking at here. The UI map.UI test has these as kind of sub-files of it. This file is the placeholder, really. Note the word partial. That's one of the C# constructs. It says this class called UI map, part of it is here, and part of it is in another file, and it's this file. So this file, again, is partial on the same class, and it has all the bits and pieces of our code. So, for example, we have the code to enter the left number, and it, generally speaking, simulates sending keys as if from the keyboard. It reads the values out of this variable and puts them into this place on the screen. This place on the screen is declared via this structure, and yeah, this is the method that enters the number, which you recall is back here in the test file, that one. And you note the method name is repeated there, but with the word params after it. So the parameters that the enter left number method uses are taken from this parameters file. In this case, there's only one field in it, but if we had recorded more steps in the same action, we could have a number of parameters there. If you was filling in a bigger form and typing in several things at roughly the same time, or as part of the same method, you'd get that. And the bulk of these files is just boilerplate code that Visual Studio gets from its templates. You don't need to know much about this file, and generally don't look in it unless you really feel you want to. The important one is this file, and out of here, if we double click on the UI map file, we get a more human readable version of what's in the UI map file, and we can make changes here, and I'll be showing you more about that later on. So back to our slides. We've got various ways of improving the testing. The main test is has the test method attribute. Attributes are put in square brackets before procedures. The test method attribute says this method within our class is a test to be executed. Before the test runs, before any individual test runs, the test initialize method can be called. You don't have to create it. If it's there, it will be called. After each test has run, the test cleanup method is executed. Now, tests live inside a class, and so before any part of the class is run, so any of the tests in the class are run, the class initialize method would be run if that is available. And after all of the tests inside that class have been run, the cleanup method would be executed. And the third level of before and after things, before the whole assembly, the whole DLL containing our tests is executed, an assembly initialize would be run, and afterwards an assembly cleanup. Now, if we have two or more classes containing tests, then the order in which the class cleanup routines is called is not given, merely that they will be called after all the tests in their classes. And these are used for setting up bits of the test environment and cleaning up afterwards, potentially populating databases or variables or making sure files exist before tests are run, and generally cleaning up afterwards, making sure that rubbish is cleared out of databases, that files are closed or deleted, general cleanup after the various tests at various levels. Again, all 6 methods with these attributes are optional. We also have a test settings file. In Visual Studio 2010, you always had such a file, and it was there to provide various controls on how the test was run. In 2012, it's optional. You don't need to have one now. If you need one, you have to create it specially. The test settings file, you can have more than one file, and they're stored within the solution folders of the test. You can have several settings files, so you might have one for each of the different operating systems you want to test your code upon. You might have one for running the tests locally on your machine whilst you're preparing the tests, and another test settings file which you wish the real testers to use when it's into production testing. When you've got a test settings file, you must select which of the files you're going to use, and you can change them as you need them, and in 2012 you create them, as I'll demonstrate in a little while. The test settings file generally contains these topics. Roles is about where the test shall be executed. Shall it be on your local machine? Shall it be entirely on a remote computer? Or shall it be a mixture where the test is executed remotely but the data from it is collected on your local machine? We can record all sorts of different data and diagnostic information as the test is running. We can arrange that files are copied into various places before the test is run. That's the deployment. We have another level of setup and cleanup we can do, and so on. Test timeouts are useful. We don't want our test to run forever if perhaps there's a fault in it. The last 2 clauses for unit and web tests don't apply to coded UI, but you recall the 3 sorts of tests you can have in the project, so these are for those other 2 test types. So a little demo again. So we come back here. We add the test settings file to the solution. There's another add menu down off of here, but that doesn't give us the test settings file. We have to add at the solution level. So right click on here, come down to add, and it's a new item. We add a new item here, and test settings is one of these topics here. We can give the test settings file a name. We'll take the default and we add it here. And we get this pop-up which has the various topics available. I'll just show you 1 or 2 of them. Under data and diagnostics, this is useful for collecting information with the test results, particularly for when they fail. Generally with this panel, you select an entry by ticking it, and then if you double left click over here, a little window pops up. So, for example, the application under test might do things that cause system events to happen. We might be worried that the test causes system events to happen, so we can arrange that they be collected when the test runs. And you've got all these different possibilities of here and different types there. So we can set that. We untick it. System information is very useful, particularly if we're running our tests on multiple different computers. We might like to make sure that our application works properly on Windows 8, on Windows 7, on Windows XP, and more. But when we give the code to our developer and says, it doesn't work, here's the evidence, and they come back with the classical line, but it works on my computer, you can say, is your computer the same as the one which has this system information? We can do recording, and with this we can even record audio. Again, be careful what you record. If the testers say what they really think about the application under test, the developers might not approve of that. Network emulation allows us to say what kind of link we have between our application under test and the, for example, the databases or the web hosting sites that we're testing against. So there's many things we can control under this screen here. I don't want to show the full set there. We can have scripts here, batch scripts or PowerShell scripts for doing preparation and cleanup after the tests. Timeouts, either on a per test basis or on the total tests, or both. These two are not applicable to to coded UI testing. Again, the roles is about where the test shall be executed with these options. So that's, yes, I want to save the test at the moment, even though I haven't really put anything in it. Now we select our test settings file up here. Off of the test menu we have this. We can select our test settings file, which is stored in our solution, so that's the one we've just created. And then up here, we have the file shown with the tick box. We can say, don't use that test settings file. We can add another one, and then we can switch between them by ticking and unticking amongst the various files that are listed up here. So that's the test settings file. Now this morning, Peter showed recording tests using MTM, and he got a script that he could run using MTM, and that contained a series of test steps. Now we can convert those recordings into coded UI tests. When I showed you the first demo, this little window popped up. So if we use the second option on this window to use an existing action recording, it will pop up the work item picker from MTM, and we can select any particular test that we've got recorded here. And we click on the OK button, and it generates some code. The code is broadly identical to what we generated previously with the demonstration I did. And it's as simple as that. The coded UI system will create a coded UI test from that recorded method. It takes the actions in our test cases and creates the recorded test there. So when we've got a manual test that was recorded under MTM. We can now automate that. All the data driving that was possible with MTM tests there is carried through and converted into the appropriate data driving for coded UI. And I'll show you about about data driving coded UI test later on. Iterations are preserved, and each method that was in your MTM test is converted into one action. I don't have time to demonstrate this conversion now. In the demo I did before, I just drove the calculator. I didn't check that the arithmetic it produced was correct, but that's always a good thing to do. So to add an assertion, so we wish to add an assertion to make sure that our calculation is done correctly. So it would be nice to do the calculation and then add some code where I put the blank line to do this checking, and to add an assertion in, or indeed to add any new piece of our test into the code. We just use the generate code option here, which invokes the same coded UI test builder as before. One challenge when you're adding new code in is you've got to advance the application under test to the position where it's applicable to do that validation. In this case, I'm just going to run the calculator and enter some numbers. But what you might do in a real test is set a breakpoint here, and just before you want the new code put in, run the test using the debugger, for example, and it will stop at that point, and then you can stop it executing, stop the debug session, and add the new code in. But I'm quickly going to run a calculator. So we did something like 2 times 4, and we pressed the equals button. So now I have a calculator in the correct position. So back in my Visual Studio, if I right-click there and invoke the coded UI test builder, we get exactly the same pop-ups before with the same command window. So what I want to do is start recording. No, I don't. What I want to do is use a crosshairs tool, which adds an assertion. Now, if I drag that up over here, you see a blue bar surrounds part of the screen. As I move the mouse around, the blue bar moves around the screen, showing different highlighted bits of the screen. Now, one thing I'd like to show is here. If I select this piece of text, now if I release the left mouse button, I get this window comes up. Now, if I drag that a bit bigger, we can see this text here, which I imagine might be useful for a person with poor sight to understand how the calculator works and what this part of the screen is for. So I said earlier, the coded UI uses the facilities for helping people with disabilities to use the computer, and that's part of how that system operates. So let's close that. But what I want to do is actually check the result of our calculation. So if I drag the crosshairs over this box here containing the 8, I get this built up. Now what I want is the display text field, and I want to add an assertion, and I get this. Now I can check various I can do various comparisons against what's on display. I can check text fields for their contents, and in this case I want to compare the number on display for equality against the result of my calculation. new feature in 2012 is this box, so I can type in a message here. And click on OK. Now this box is in the way of this thing underneath. So now if I generate the code for that, let's call it check result. Add and generate, and close that. So now we can see I have my check result code has been added into here. So I'll just tidy up the blank lines. I don't need this calculator anymore. And I can simply run the test. So down in the bottom left-hand corner you see the build messages. The grey bar now has the moving green thing, and the calculator's running and is finished. And something went wrong. So on the left-hand side I can see the message I typed in, result not as expected. It expected an 8 and it's actually got a 10. Well, I cheated here. I knew I was expecting 10 by multiplying 2 and 5, but I deliberately typed in 2 and 4 just to confuse us all. So if I come over to the UI map file and edit that, under the check result, if I view the properties of this, then over here in the properties window, I've got the expected value field, and I can just change that to the value that is
Welcome to Workcast's conference.
Your call is being placed in conference.
You know, everyone will be asked to say their name. You'll get 37 different people joining and people periodically leaving.
I've been putting this on the screen.
People. Excellent. So just keep lots of little messages or keep people on the hook. As long as you don't use it too long, they'll stay with us, I think. Because we've got 30. How many on there, Ian?
When did it go?
A minute ago. 2 minutes ago. How many on board here?
39 at the moment.
I think probably got 3.
So obviously people are dropping out and trying to go back in.
Audio's back.
Audio's back.
I believe the audio is back. Are you getting that, Ian?
Yeah.
So I'm told the audio is back now, so I will resume my presentation so this little message can disappear. Don't need that anymore, definitely. Okay, so I was just showing you that we had a test failure with the expected 8 and the actual result on the screen was 10. So I showed opening the UI map file via the editor, selecting the check result field and selecting its properties, and then coming down here, just before the audio failed, I changed the 8, which was in this box, to be a 10. And then the audio failed. So now we have the correct answer here. Note just a little issue. Up here we've got an asterisk by the file name. That says the file has been edited but not yet saved. Visual Studio is very good for us because it generally, in fact I think always, saves files at the right times. So we don't actively need to do a save. We can just come back into our test program and run the test again. If you watch the asterisk, it vanishes, saying that Visual Studio saved the file for us. But the moving green line, the calculator appeared on my screen and disappeared. The grey bar has gone to solid green, saying the test all passed. So what we've done here is we've created our test which performs a series of operations. We've checked the result of doing that operation, shown what happens when the check fails because the result is not as expected, and then corrected our test. It's not always the application that's at fault. The test itself can be at fault, and that was the case here. We've corrected the test and rerun it, and we have a pass. So that's how we add assertions in. Now, back on the topic of recordings converted from MTM, you would need to do something like that, like I've just demonstrated, to add assertions in to correspond to the manual checking actions in the MTM recorded tests. And once you've added suitable assertions, your previously semi-automated but with manual checking tests that you ran under MTM can now be fully automated. So you can, in some sense, click on the Run Tests button and it just goes away and executes all of the tests for you and comes back with a pass or a fail as appropriate. So here in our slides, we've added some assertions. Peter described data driving tests in MTM. We can also drive them in coded UI, and we can add our own data driving. Visual Studio's 2010 are different. In 2010, we had a data source generation wizard. It doesn't actually do very much. It was nice to have, but it doesn't do very much. it was withdrawn in 2012, so we have to write the code ourselves. Data driving, we're just going to run the test a number of times. It's easy to record a test once with one set of data. It's not that hard to record the same test a second time with a different set of data. But when we want to record it, with more sets of data, it gets tedious. If we've got a data field which takes the values 1 to 100 inclusive, it might be nice to run a test against that data field with a value like 45 and a value like 80 being representative normal values of that field. But we also want to run it with the value 1 and the value 100 because they're the end points of the possible values, the boundary conditions. It would be nice also to run the application under test with the value 0 and with the value 101 to see that it behaved in a sensible fashion. It produced the correct error message or whatever is the appropriate response. We don't want the application to just crash. We also might want to, rather than putting a number into this number field, put some letters or an asterisk. So were we to record each of those possible tests individually, then when the application changes, we would have to go and modify each of those many tests one by one, and that's a recipe for getting adding errors into our test cases. So if we can have one test which takes all these different values, then we only have to change in one place. Now, of course, if we have error values in our test cases, values which produce errors, we've got to make sure that our test suite properly handles those error cases. That when the application reports errors, then our test code will properly look after those errors. We can run the data in our test cases sequentially or randomly. Running it randomly might be useful if our application has some kind of memory from one test run to another. It might be an unintentional memory. It might be something related to an uninitialized variable, which is just remembering numbers and using that remembered number in the next test. So running them randomly means we're more likely to provoke such a test failure because of such an issue. We add the data, we make our test data driven by adding a data source attribute to the code in the same general position as the test method attribute was placed. Having got our test data driven, we've actually got to pick the values from somewhere and put them into our test. And the test context variable contains the data row fields, and our data comes from there. Generally, you make the changes for data driving in the coded UI.cs file and not in any of the other files. And you've got to make sure that the source data of this test is available. So this means deploying the test data appropriately. Our data sources can be of many types. CSV files are easy, and that's what I will be demonstrating later. XML is also quite popular, but has a more complicated file structure for just people to read. We can use a variety of database types. Generally speaking, any of the popular database formats that have ODBC drivers available. So we use coded UI for iterating a test many times, or we can use data driving to call any of a series of different tests. We could have one column. If we're using a spreadsheet as our source, we can have one column of the data naming the different tests we want to run in some sense. We can have control-based testing, a more complicated variety whereby the data-driven fields say, visit a window called, and it gives a name. Within that window, visit a sub-panel with a particular attribute. Within that sub-panel, find a button with a particular name and click it. In the same way, it could find a text field on the panel and type some text into it. So we can build a complicated test structure which is entirely driven by our data file. Now, this would allow people who are not good at writing code, not good at writing C# or whichever language we're using, to actually drive tests by entirely writing the test within the data source. But it can be complicated, and it would be easy to mess up such tests. And finally, of course, we can have a whole mixture of these topics. In 2010, we added the data source by firstly going to the test view window and then selecting our test method. Sometimes we needed to press the refresh button, which I've given number 2 there, and then we select the properties of the test method we're looking at. And in the data connection string, we clicked on the ellipsis, and that would invoke the data source wizard. I say they've withdrawn that facility, so in 2012, on the left-hand side of this screen, I've got some code which was just copied from the very basic test as generated by coded UI testing. We replace the test method attribute with the text that's on the right-hand side of the screen. And I must apologize, the red boxes seem to have drifted on the page a little bit on that screen. The file that contains our data source, if it was a CSV file, we have to name in 3 places, which should have been wrapped in red boxes, but I say the boxes have drifted. The middle one has a hash, not a full stop, and I haven't understood why it's different. The data directory in the top one of the 3 refers to the directory from where the test data is read. And with the vertical bars around it like that, it relates to the deployment directory of the application. So this is the method we use for putting a CSV file as our data source, and we use very similar strings for data sources of other types. So let's data drive our coded UI test. So over here on my desktop, I have some text I prepared earlier. So these are examples of the text we would use for different sorts of data source. We can read straight out of an Excel file, a spreadsheet, and at this clause in the line, we can name which sheet within our spreadsheet is appropriate. We can also get data from TFS, from XML. There's an SQL Express version of the data source line here. And this block of text is obtained easily from the Microsoft website. So here's one I prepared earlier for the data file I'm going to be used. It's just the same as the one at the top of this file, but with the right file names in it. So I'll copy that. I'll come back to my test code and I will take out the test method and put into it this data source that I've just created. Now I need to associate the testdata.csv file with my code. A good way of doing that is to right click on here, click add, and add an existing item. The item will be the file. Now I've got the file on the desktop of this computer. I need to specify all files down here so that I can see it. I come down here, there's my test data CSV file, so I just add that into my test, and it appears over here. So if I click on that, you can see it's a simple CSV file. I've got 4 columns for the left number, the operator, the right number, and the expected result of the calculation, and here's some sums to be done under my test. Now what I also need to do over here is make sure the test file is copied into the right places at the right times. So if I select the properties of the file, they appear down here, and this copy to output directory field is defaults do not copy. I've found that copy always is the way to go. Generally it's only a small file, so you're not going to hurt anything by as if you're copying megabytes of stuff. So if you copy always, the file will always be where you need it, when you need it. And then what we also need to do, back in our coded UI test file, we need to get the data out of that file and put it into our test. So if we just make some space here, then back in this trusty file here, I've got some lines I prepared earlier. So I just copy those and paste them in. And make them visible when I can find the drag bars. Right. So what it says is, into the parameters field of the method for entering the left number, take out of my test context the contents of the column called left, and make sure it's a string. In the same way, for the operator, we pick out the operator column and the rest. Note that the check result method has expected values because this is an assertion we're checking, whereas these 3 up here are parameters values because they are putting data into the method. That's a matter of personal style. Now, some people like to move these lines immediately above the corresponding method call here. The only important thing is you should make these assignments before calling the corresponding method. So I'll leave it at that. I believe that's all I need to do. So I've done 4 basic topics. I've replaced the test method with this. I've added this file here. I've changed this to copy always, and I've pulled these numbers out of my spreadsheet and put them into the relevant fields. So now I can run the test again. So simply right-click in the source code, run tests, and again, at this point I should put my hands in my pockets so that I can't use the keyboard and mouse and interfere with the running of the tests, which in this case is going to run the calculator a number of times. You can see the calculator popping up on the screen. You can see the green bar moving in the top, and it's changed to a red. Something's gone wrong. So what has gone wrong? Let's make this a little bit bigger. So if I scroll up and down here, whoops, I can see that data row 0 has passed, data row number 2 has passed, data row number 1 has failed. A result not as expected on data row 1, 7 against 5. So if I look in my test data file, we have a quirk of numbering in Visual Studio now. This is data row 0, so that's data row 1, and that's data row 2, even though I might call them lines 1, 2, 3, and 4. But when I look at data row number 1, I see 15 divided by 3, and it's expecting 7. Well, that's clearly wrong, isn't it? My data is wrong again, so that should be a 5 at that point. So I can edit my data file. You'll also notice this plus sign has been wrapped in curly brackets. This is a quirk of how text is handled in the send keys method. Some characters are interpreted as shift keys or as control keys and have other interpretations. The plus sign is one of these characters which is interpreted specially. So I need to wrap it in curly brackets. It's all documented in the Microsoft documentation. It's just another little point to be wary of. So again, I have the asterisk at the end of my file name. Just keep an eye on that. If I come back to here, I can right-click in here and run my tests again. So watch the asterisk that disappears to say that that file has been saved. In the bottom left-hand corner, it showed the build taking place, and now it shows the calculator being run again. The green bar's moving on the top left of the screen, and it's gone to a solid green bar showing all my tests have passed. So data driving is as simple as that. So that's that demo done. What I've shown you so far really is a small application. We can test much bigger structures with that, and when we get into bigger applications, we need to start being careful about how we lay out our coded UI testing. It's useful to use multiple UI maps. It allows us to have more than one person contributing to the complete test suite. We can have each person has their own UI map file for the portions of the test suite that they are working on. We might like to have one UI map file for each major screen of our application. Generally, we want to divide the test case, the test suite, into smaller, more manageable pieces so that we can work on them separately. The big file gets complicated, it's hard to manage, it's hard to see in a big file what is useful and what is old stuff that should perhaps be deleted. So generally we're talking about modularity. We're talking about isolating different parts of the problem one for another so we reduce the undesired interactions. It allows us to abstract bits of the test. It allows us to create our tests incrementally. We can build part of our test in one UI map, and then as the whole application evolves, as the test suite evolves, we can add a new UI map for newer parts of the application, and perhaps over time we can retire entire UI map files as the application evolves, and as the test suite correspondingly evolves. This expresses most of that in a slightly different way. You can break down the UI map into different topics, so you can scale the application in a much bigger sense. It encourages support. It allows us to keep the functional areas separate one from another. As we're working with multiple UI maps, remember the uimap.cs file. As particular bits of editing need to be done, we can move bits of code from the uimap.designer.cs file into the uimap file, and once there, they won't be recreated, they won't be lost whenever we regenerate the uimap files. And just a small tip is, keep the UI maps in their own folder within the application. There's no need to have them contributing to the main folder. It can mean the Solution Explorer is neater because it has a particular topic for, a particular place for UI maps, and it means that the Windows folder structure is simpler, again, for the same reason. So large applications have the same problems as the tests for these large applications. It's just a matter of complexity, quantity of modules, amount of code, and so on. So the best practice is to keep separate UI maps for separate areas of the code, and keep the methods in your test down to, small related topics of activity. When we're testing more complicated applications, we might want to add our own data into the test results as things run. We can take screenshots of the whole desktop using the top line code, like the top line there. So into an image file, img1, we get an image of the desktop. Again, be cautious on that one. If you're testing on your own desktop, then make sure that any private windows that you wouldn't want the developers to see are not open. A way of preventing that is, as in the second line there, use the UI map. Use a subfield of the UI map and capture the image of that. And then we just call the save method of the image class and name the file, and we have to name the file type that we're saving as. But we can create files of all sorts of types. It's quite straightforward to create a text file containing some kind of logging information or the results of bits of our test run. Create the file during the test, perhaps per test case or perhaps over a series of tests. Remember, I talked about the various test attributes, attribute classes for test initialize and test cleanup, for class initialize and class cleanup, and the assembly versions. So we could write data into files which we open and close at that level. And then within our tests, or perhaps within the cleanup routines, we can call testcontext.addResults file and name the file we've just created to store that in with the results. Just be careful about the paths used for these file names. You just got to make sure you're getting the path there correct. But remember, test context as the field has a variety of directory fields within it which can be used to get at different directories within the execution of our test, different parts of the results, structures, and where the test came from. So also, what I've shown you so far in the demos and discussion has been working at straightforward testing. We do get some concerns in other cases where the tests don't work quite as we desire, particularly things like timeouts. If we have an application that starts running and because of a fault in it, it just never stops. It goes into some kind of loop. Then we want our test to stop at some point. We don't want our test to run, for example, unattended all night, just wasting time on that test and not running any other tests. So we'd like to time out the test. We might have written a bad test suite where the test suite loops, wasting time. So again, we can have timeouts for abandoning a test or a test case so that the system can go on and try additional tests and hope that some more of those pass or give useful results, but generally so we get more useful data out of running our tests. Some applications are asynchronous. They do two or more things kind of at the same time. That's what asynchronous means. Writing tests of such applications is more complicated. It can be done. It just needs more attention paying. Events much the same. On the screen, particularly with things like web pages, it can take time for a web page to display completely. It might have a complicated search back in some server database. Our application under test may take some time to calculate its results, and so we have a series of routines available for testing the timing. A series of routines available for testing the timing. I do beg your pardon, I'm confusing myself with what I'm saying here. We have a series of routines available for checking that what is on display is available and ready to be tested by the coded UI test system. The coded UI system works very hard to make sure that what is on display is there and correct, and so we can, most of the time it will do the necessary weighting for us, but under some conditions we have to do the weighting ourselves. This can be annoying, the way it works, because if a test is not proceeding in the way we expect, then coded UI might spend up to, I think it's 2 minutes by default, waiting for something to come on display on the screen before saying that object is not on the screen and therefore it's never going to be on the screen, so coded UI moves on to the next stage of what it's doing. Or it says it's not there and therefore the test has failed. We do have the ability with coded UI to tell it to fail a test or not fail a test when items on the screen are visible or not visible. The default is that it will fail, but we can change it for small portions of the screen so that it won't fail. It will recognize the absence of something and it will just continue processing. Something more I wanted to say there. So, what are the best practices the coded UI test builder. I've shown you recording tests with that. I've shown you a bit about doing assertions, generate assertions with that. I think the recording facilities of that are very powerful and allow you to, with the crosshairs tool, to explore the screen, to understand what is drawn on the screen and how you might test it. I've read in the forums people saying, don't use it, it's horrible, it's terrible, it generates bad code. I'm not sure I agree with that. You know, we always get the argument, it comes from the very early days of computing and compilers. People said, this compiler's terrible, I can write better code in assembler. But who says that now? You know, computers are so fast, we use the compiler because human time is more important than wasting a few machine cycles. I think in much the same way, using the coded UI recorder allows you to get a good understanding of what the application is. The UI map designer file is regenerated each time we change the UI map file. So don't change text within that file. If you need to make changes in that file, or if you think you need to make changes within that file, stop and think again. If you still think you need to make changes in that file, move the code into the uimap.cs file. Remember I said partial class and across the two files, and then edit the code there. When you're recording tests, don't put too much in any given method. You know, perhaps each page, each dialog box is worth recording into one method. I was looking at an application recently which had 20 or 30 forms on one page. 20 or 30 fields, I beg your pardon, on one page. And, you know, that's getting a big method if you're going to fill in all of those fields in one go. It makes modifying the method complicated. So probably split that into 2 or more methods for such a form. And meaningful method names. Our test code is going to be written once, but it's going to be read many times. Each time a test fails, we're going to have to read the code of that test to see what the issue is. The more goodness we can put into our method names, the quicker people can read through them and understand what they are and understand if they're relevant or not relevant to the problem we're looking at. So let's have a little look at the some of this editing here. Within the UIMap file, I showed briefly this editor before. We've got a number of things we can do. Over here, we've got all the different operations that we have done. Now these are deliberately chosen to be very small operations, just to demonstrate what was happening. But we can modify our code via these various options here. We can delete entries from the list. We can go in a big file. We might need to go searching for entries here. We can rename items. When we've chosen a name, we might find that we want to rename it to something else to make it more understandable. If we do something like that, we have to be careful because we get this pop-up saying that the renaming is only done within this UI map file. So by hand, we have to go and edit the places that method is called from. And now if I select yes on this, note the edit asterisk is shown up here. if I just close this file, it says, do I want to change it? Yes. Now we do, one of the many things that Visual Studio is helpful about, it shows a wiggly red line under here. And if we tried to build it, it would grumble at us that calc was not defined. So here we need to rename this to use the correct procedure. And the syntax semantic checking as you type sorts out that now it knows what that method is. Other actions we can do are splitting our method into multiple pieces, which is jolly useful when we've got big methods and we need to modify them. We can add delays into, I just clicked that. It adds a wait action there. Generally, we can look at the properties of these actions to find different things on the screen. I haven't talked about this area of the screen before. This is the actual UI map, and these were the actions. And over here, this is how it finds pieces on the display. So if we look at this, for example, this field here, if we come down and look at its properties, which are on display here, the coded UI system searches for this window via the features in this search properties thing. If I click the ellipsis down here, it shows what it's looking for. In this case, to find that window, it searches for a thing with control type of window, which is an MSAA thing, and the control ID, just a kind of magic number, is 150. I don't remember what 150 means, but we have the option to modify these structures. Now this is particularly useful when we're looking at web pages. For example, Internet Explorer, when you start it, is likely to say Internet Explorer made by Microsoft as the title of the program. Let me just check this. I was looking for a title name, but you get a name field here and calculator. This entry on Internet Explorer might well say Internet Explorer made by Microsoft. And then when we visit a page within our browser, the window title often changes to Internet Explorer, and it gives the name of the page. And then we find that our test fails because it's got the wrong title. So this is a mechanism for modifying things to allow us to get the correct window. And often we can do things like here, changing this from equals to contains. So we could change our title from to say the title contains Internet Explorer rather than it equals Internet Explorer. And this will make our tests more likely to pass. Conversely, it might find more than one window matching that title, so we have to be a bit careful. So I cancel out of that piece. Another good facility here for when we're trying to maintain our maps is the locate command. Up here we have locate. We can right click on these things generally as well. If we say locate for control, it thinks about it for a while, and if I give it long enough, it will say it can't find it. I mentioned earlier how Coded UI has a default timeout for saying I've been looking and I can't find the control. And after a while, it will time out. Oh, there it has now. You get an equivalent message to this within errors on your test runs. So if we actually have a calculator here, here I have a calculator. If I now come back to this window and say locate, very quickly it finds the calculator and draws a blue box around that component of the screen. If I come back here, if I say select something here and I say locate all, it finds which parts of the UI map underneath that part, considering this is a tree structure, it finds which parts of that are available on the screen at the moment. So this is a mechanism for finding bits of the UI map which are no longer needed. I said as tests evolve, you want to cut down what's available on the screen or what's available in the UI map to just keep it correct for what the tests actually are. So everything with a tick on it has been found on the screen. If I take it a different level and say locate, I clicked the wrong locate there, that's finding that one again. I beg your pardon. If I click here at locate all, it clears the ticks underneath that control and finds them again. So this UI map editor was added in Visual Studio 2010 Feature Pack 2 and is available in Visual Studio 2012 by default. Very useful addition to the program. So back to our slides. So best practices, again, using assertions. We can use the coded UI test builder to view parts of the screen, to check what is on display, to check that text fields contain the correct message, that calculation results contain the correct number, that database inquiries which display something on the screen are showing the correct text on the screen. When a UI changes, we might have to re-record methods that are affected. Now, Visual Studio goes, with the coded UI system, goes to quite a lot of effort to try and isolate the test from the very fine details of the user interface. So it does not record the full tree structure of how the UI is built. It just records the salient or significant aspects of it, and then when it's trying to find a control, it goes searching for the control based on the search properties that I showed earlier. So many changes to the user interface will be accommodated by Visual Studio, as it won't mind. Particularly things that just about moving a button or a text field from one part of the screen to another, that will just be normally absorbed without any problem at all. In terms of making changes, we need to advance our application to the point in its execution, which is the correct point for where we would need to make the change, and then we can use the recorder from that point to record new actions. If we've got a complicated method for our testing, it might be useful to go into the UIMap editor and use the split operation to separate the method into pieces above and below where we want to make the change, and then maybe delete an action or two there and re-record those pieces. By splitting the method into sections, we then perhaps only have to re-record a small piece of the complete action. In terms of modules, it's useful to create separate UIMap files for the different parts of our application, perhaps for each major screen, perhaps for each person who's developing tests, so that they can develop their piece of the test independently of other people. It's avoiding that normal problem of shared files and being updated by two or more people at the same time. We want to use meaningful names for our controls so that in the future we understand what really was happening, and so that the people who take over from us can also understand what that piece of the test was about. And in the same sense, remember in my first demo I showed the comment box on the recorded action. Make good use of that to add meaningful comments into the recorded actions. And the coded UI system puts a lot of good code into the designer.cs file. It's there to be used in the sense of being called from your test files. So just be aware that it's there. It's got a lot of powerful facilities in it which have been made by the coded UI system. Before I did this, I wanted to show you one more thing on the demos. Just in terms of coded UI maps, it's convenient to add a folder. Can't find new folder. There's new folder, which we can call something like UI maps. And one little thing which confuses, here we need to add a new item which is a UI map. I can never find this when I start looking, so let's just sort by name. Still can't find it. Where did it go? There we go. No. Coded UI test map. I do apologize. My cold is getting the better of me, I'm afraid, and my mind is going. Coded UI test. We create a UI map file here, which we'll call it calc because I've been calc. It's also quite useful to keep the name UI map in there somewhere. And having created this file, it immediately brings us into the test builder here, so we can do our normal recording things. I don't actually want to record anything at this point, but having got a UI map file here, when we want to add new actions in, we should always edit it with a coded UI map builder here via this route. If we come back into our main test file and invoke the recorder here, it will put the code into this UI map file. And if you've carefully not created this file, you've been working carefully in your own UI map files over here, then the coded UI system will quietly and without warning create a new one of this file for you, which is not always what you want. So my message here is generate, when you've got multiple UI maps, generate via this route. Oop. And so I want to go back to pretty much my last slides. So we just want to know what should we automate and what not. When should we use coded UI testing? And it's basically a question of cost and suitability. If we've got something that's going to cost a lot of money to build the tests, then maybe we shouldn't automate them. Maybe we should automate part of the test and not others. If our application under test, for example, takes a couple of forms we've filled in, does some database inquiries, and generates a fancy report in Microsoft Word or as a PDF file, then perhaps our test should merely say, does it take the data, does it generate a document? And then we should let people study that document to see that it contains the correct results. If our application is all about doing some complicated calculation, I'm thinking financial trading or tax planning or something like that, where the actual calculations are hard work, then it doesn't really make sense for us to write a test suite that validates that the calculations have been done correctly. We can validate that calculations are done and an answer is produced, but maybe we should leave it to people to study the answer that's produced. So we have a mix of manual and automated testing for that thing. And what was the application like? Has the application actually been built with testing in mind? If we are working in the same company as the people developing the application, then as testers, we can say, I've tried to test your application. I'm having some problems. Can you please enhance it in particular ways to make testing better? You then have the argument about, I shouldn't change the application just for testing it, but, you know, that's not an argument that's particularly strong when it's going to cost a fortune to not have that small change in. So, some tests, is there any benefit in automating them? If an application is used very seldom, it might not be worth automating it. But equally, if it's used very seldom, it might be an ideal candidate for automating because it's seldom used, then people keep forgetting about it. And then when unintentional changes are made to it, because it's so seldom tested, people don't notice, so maybe we should automate the testing of that application so the computer looks after the boring bits of testing the applications that we are bored with. We have a question of, should we have a big test to test the whole thing in one go, or do modular tests? When we're automating, you know, how robust should we make the test? We can write tests which are all-encompassing and test all the error cases. Maybe that's going too far. Maybe we should test a portion of the application and not test all the edge error cases. So, thank you for listening. If there's any questions, and I think there's one or two have been passed around. I haven't had a chance to read any of them yet, so if you'll give me a couple of minutes to read them, and I'll come back to you.
Thanks, everyone. Thank you for joining us. Thank you, Adrian, for that excellent presentation and for obviously giving us a brief overview of coded UI test automation. As Adrian mentioned, he will again, please apologize. He will sort of take a minute or two to just familiarize himself with the questions that we have. We have been inundated with questions. We will again try and answer them as much as we can. If not, then again, as I mentioned previously, we will take some of this on offline after today's training, and I'll get my colleagues, Adrian, Peter, or my colleague Ian, who will be coming on soon for the session, this afternoon session, to answer your questions individually. Once again, I do apologize for the audio earlier. Just a bit of technical issue there, but hopefully that didn't make anything worse or anything like that. So give us a few minutes, please, and Adrian will come back to you in answering some of your questions. But please do keep your questions coming in. Just whilst waiting for Adrian to sort of familiarize himself with the questions. Oh, hold on. I think Adrian is actually ready. Give me 1 second.
So I've got a few questions here, which I'll have a go at. Silverlight, yes. In 2010, Silverlight was supported. In the first release of 2012, it was not supported, but it's Feature 1 CTP4, Update 1 CTP4 it's called, which I think was released at the end of October, the last day of October. That supports Silverlight now. There's a Microsoft blog entry discussing Silverlight. No, it wasn't in the CTP. I think it was in something more like a Power Pack or a, what do they call it? One of these informal Microsoft releases. It's mentioned on one of my slides earlier. I'm not familiar with Microsoft AX packages, so I'll have to come back on that topic. In terms of who develops coded UI tests, it's the developers and the testers. One common route, I believe, is that the testers say, we would like a particular range of testing doing, and they bring in a developer into their team to actually craft the testing initially. It depends on the skill set of the testers and how much development experience they have, I think. The purpose of coded UI testing is much greater than developer testing. I think it's expensive to use for developer testing. I think coded UI testing is part of the formal test process of your application or your web software. It's very useful for regression testing of the application, the sort of testing that you want to run repeatedly after every major release and often after every minor release of your software, so that you know that the basic functionality continues to work. Particularly what happens is the developers and the testers spend time working on the new exciting parts of the application, and the old established parts are considered to be less important. You know, we can use the word boring against them. You know, it's a bit derogatory, but that's what computers are good at. So if we can give the computer the testing of the old bits, and it just happily goes away and tests them on its own, and hopefully most of the time tells us it's all okay. The UI map is associated with, they're held in the solution, no, held in the project. The UI map is associated with the whole of the test suite you're doing. It's part of the test suite. So it's on a par with the methods in your source code of the tests. It's closely allied with those methods that have the test method attribute. Neither is at much use without the other. And you can have multiple UI maps within a test or a test suite. In terms of number of actions in a recording, you can record as many as you like. There's no particular limit. What is worth doing is having a small number within any particular method, just so that you're not making something too big and too unwieldy. A separate map for each screen would be a good thing. A separate UI map for each major screen, each form on the page, and again, possibly a separate UI map for each developer in the team, so you don't get the problems of two or more people trying to modify the same UI map at the same time. In terms of screenshots, there's a couple of ways of making screenshots relate to individual test runs. You can generate different file names or something for each test. Yeah, a different file name on behalf of each test, and save them there. And separately, you can use the method I showed you, which whose name I've forgotten, is add test file to results. I apologize, I've forgotten the precise name of it. But that method, which I showed you on one of my previous slides, will, here we go, add result file. This add result file method will attach the file into the results of the particular test run, and so the saved image won't be overwritten each time you run the test. Performance of tests, there's a whole lot of stuff on that on the Microsoft web pages. They're a fount of wonderful information on how to do that sort of thing. So I think that's it. Thank you very much for putting up with my talking. I'll hand the microphone back to Mel.
Thank you, Adrian. Again, if we do, my colleague Adrian will take some of your questions offline after today's training.